I'm Jordan Jankus with ARC of Westchester, and what I try and do each day is to help people learn about the power of technology in the lives of people with cognitive difficulties. So, let me just give you a little information on what we're doing here at ARC of Westchester. At this point, we're doing about somewhere between 6 and 7 webinars a month. And we've made the webinars now all public. You can go to our arcwestchester.org/technology page, and you can see our main webinars. We have the Tech Learning Exchange, which is kind of geared at people that are in the field, professionals, people that have some tech background. Our Tech Ambassadors webinars, those are ones for staff where I try and give lesson plans to people, things that they can use in their vocational and day programs with the individuals that they serve. They're very short webinars, maybe around 15 minutes. So just bang them out, and then I post them to the site. And then we also have a Take a Bite lunchtime seminar where I have various manufacturers and service providers in the tech field talk about their products. So we have a lot of variety, and we try and spread it just as a matter of public outreach. There's so much information out there about tech, but the hardest thing, I think, is finding out about it. So please go to our technology page and take a look. Lots of great information. Let's get on with the matter of the day. I have the wonderful Jon Morris from JDQ, and also Three Spheres Robotics Project, and he's going to be talking about unbelievable, but robots in group homes. So it's a very exciting topic. So I'm now going to switch the screen over to Jon, and this just takes a moment. Through the miracle of the internet, we should be seeing, yes, we are seeing Jon's screen. So it's all yours, Jon.
Great, thanks, Jordan. And good day, everyone. I understand we're from different sides of the country, and that's interesting. I'm in Vancouver, Canada, and I had the opportunity to meet Jordan and get to know ARC and a lot of the other people in the community at the Coleman Conference this year, where the Developmental Disabilities Association and my company, JDQ Systems, did a presentation on what we were doing in the technology area with respect to robots. So just to give you an overview in terms of who we are. So JDQ Systems is a for-profit company that has been closely engaged with the Developmental Disabilities Association in British Columbia, Canada, and in particular in the Lower Mainland. We are a company that develops custom software for businesses and organizations, both for profit and nonprofit. And in 2015, we thought it would be really interesting, and I guess it would keep us interested in what we're doing, if we could take all that experience in custom software development and apply it to the whole area of robotics and machine learning that seemed to be has been growing over the last few years. And we had been developing applications and working with the Developmental Disabilities Association for over 10 years. And we approached them and said, how would you like to partner? We'll provide pro bono support for a development of a robot in one of your 23 group homes, and maybe we'll expand that to other group homes as we go. And Developmental Disabilities Association had a history of trying to move into the technology world with everything from planning systems and costing systems for people with developmental disabilities, and iPads and technology and learning tools and that kind of thing. So we decided to partner in June 2015, and with the goal and the vision of creating a collaborative service robot that would help people with developmental disabilities become more independent, and in that, thereby also helping the staff in the group homes. So a typical group home for DDA would be 5 or 6 adults and 3 staff, 24/7, and basically they have 23 of these group homes, and they have this huge problem in that they cannot hire caregivers fast enough. There's government funding for the group home, but they have a incredible challenge keeping those 24/7 staff in place, both because I think there's other jobs out there that they would rather work in, or there's the aging population, the huge demand on caregivers in general, and then also low wages that are limited by government funding and that kind of thing. So DDA thought that if they could have a robot in the group home that would help staff free up their time that's used on tasks that are not as value added with direct interaction with their clients, that maybe they could deliver a better service. And so that's what we set out to do. And quite clearly, what we didn't want to do as a partnership was we weren't out to develop a robot that was a companion. In fact, we deliberately wanted to develop a robot that was a concierge and would serve in that respect. And I'm going to go into a little bit of detail on the kinds of things that the robot does, and the partners and how that grew, because I think it's an interesting model in general in terms of how we put together the research partners. We'll look at some of the use cases that the robot, we worked for 6 months with DDA staff and clients trying to figure out, what they wanted this robot to do. And it was very much a dream kind of scenario, because, it was like going into the world of science fiction, trying to figure out, what was possible and what was necessary. And it was very interesting.
Jon, could I just ask you a quick question? The people
Yeah.
that you were dealing with in the group home, did they have much experience with technology? Did they have any smartphones, or were they sophisticated technically at all?
They had just introduced iPads and various applications that helped with communication through icons and gestures and things like that. Mm-hmm. Other than that, they had computerized planning systems that allowed them to work together with their clients to establish an annual plan and cost it and that kind of thing. But that was about it.
Not a high level of sophistication.
No, but a strong desire to explore this area for sure. Like that came right from the board of directors, that exploring technology and taking advantage of it was one of the main goals.
Great, thank you.
So we basically put together we grew over 2 years. We realized that it was fine for JDQ to put in pro bono funds and for DDA to put in the time and effort. But what we really needed to do was get the experts, like the PA. In robotics, really we're dealing with a minimum of master's degree. Most of the people working in the field are PhDs. and they've got a lot of academic and research experience. And so we put the challenge to some of the universities and said, how would you like to put your knowledge and research to action in a real world situation in a meaningful way? And so we partnered with, at this point, we have 3 universities working with us, University of Toronto in the east. So even though, we're 2,000 miles away from Toronto in Vancouver here, this initiative has expanded across the country. And so we've got Toronto involved. UBC is University of British Columbia, Computer Science and Mechanical Engineering. And Simon Fraser University is the second university in the Vancouver and British Columbia area. So in all cases, we're engaging with computer science department and the mechanical engineering. Those are the 2 areas that actually contribute to that are working in robotics most strongly. And to help fund that, through the Canadian government, there are research funding organizations, MyTax and the National Science and Energy Research Council, and they allow industry partners like us and universities to collaborate with nonprofits so that we can bring together these 3 spheres. We call them the 3 spheres of reciprocity, because it's this idea of if you look how the helping sector and then the learning sector and the profiting sector, when we hit that hot spot in the middle, that's where all the magic happens, and where everybody's getting something from each other. And so we've used that model of bringing together helping, learning, and profiting, so that there's a lot of reciprocity, and it's been very successful in developing this project over the last 2 years. So basically, let's take a look at what we decided to do. So we spent 6 months as a group directly with DDA staff and clients, looking at the various use cases. And by the way, I'm going to be showing you some videos of a robot and where we got to, so that'll be the second part of the presentation here. But basically, what we decided and what the DDA thought they needed, well, let me take a step back. When we asked, and maybe I'll ask you, but you don't have to respond, but think about for a minute, what would you like a robot to do for you? And in essence, we asked that question, and we asked clients that and staff. Well, from a staff point of view, the number 1 answer was, well, we'd like it to clean, clean house. So in fact, it bordered on robot slavery, but sometimes. But yeah, it was quite interesting that all those kinds of that grunt work, that was the big thing. And then from a client's point of view, what I found interesting when we asked is that the number 1 item that came up was that they wanted the robot to give them a bath. Huh. Yeah, and I thought that's interesting. But of course, if we were all in that situation and we needed assistance in that way, that perception that the robot is not human is actually an advantage in terms of personal things and maybe even privacy. So now, of course, one thing that is probably the last thing on the list would be having a robot give a human a bath, because batteries and electricity and water just don't go together well.
A little dangerous.
That's right. So interesting enough, we do in other projects, JDQ works with underwater autonomous vehicles as well in the ocean, and so it's not impossible to have all that electronics in water. But that was their key thing. But when we started to look at, when you do this kind of project, you got to look at the low-hanging fruit, and you look at things that add value but are not technically impossible. So what things boiled down to is that, first of all, is that navigation became, and in particular, autonomous navigation. So nobody wanted cameras on the walls or inanimate objects. So basically, the home manager and the clients just wanted the robot to be able to take care of itself. It didn't want to be directed by a joystick or anything. So it was important that it map the facility. So a group home, it could actually map it out. And the way robots work indoors, they don't have the benefits of GPS. And so it's kind of like the old days where you use landmarks to navigate from place to place. It's the red barn on the right, turn left there, that kind of thing. And so what it does is it uses sensors and lasers to identify walls and furniture and map out the facility. And then using voice commands, the home manager can identify spaces like the kitchen or the bedrooms and that kind of thing, and various routes, like what's the safest route through the house, what's the fastest route, what's the most social route, for example. Where are the obstacles? How can they be avoided? And what areas should be restricted? Like perhaps at night you don't want the robot to go into bedrooms because people are sleeping. So based on calendar scheduling, those spaces that need to be restricted. And of course, from the safety point of view, there has to be buffer zones between clients and staff and the robot itself. So that autonomous navigation became important because that not only would it be able to go into the nooks and crannies of the house and discover what's going on, areas that cameras have a hard time seeing, for example, but the actual movement and behavior of a moving object like that, it's very easy for clients and staff actually to suspend their disbelief and that this is actually an inanimate object, and that it's actually something that they can interact with socially, and maybe it can reduce anxiety in the group home as well through its behavior. So the next thing was, and this was the big ticket item, is that navigation seemed to be the foundation, but what was it going to do if it could get around? So the whole idea of client monitoring, and I'm just going to focus on a couple here, that one of the key things is that in order for the robot to be intelligent in terms of interacting with people, it needs to know who they are. And so it currently uses face recognition to identify the client. We're having success around the 85 to 90% rate, and consider that you might see people from an angle, and that's more challenging. But basically, we use machine learning and neural networks to actually train the robot to recognize all of the clients and staff in the group home, and thereby it knows who it's talking to, and it has access to information about the person it's talking to, like their likes and dislikes, and that can contribute to a more socially interactive.
Can I just ask a quick question on?
You bet, yeah.
When you're doing this, like if you have people that are in wheelchairs and then you have staff, you're dealing with different heights of recognition. Like, if they're like at the level of the wheelchair, that's one thing, but it accommodates to different heights of people, like,
Absolutely, yeah. In fact, it also identifies whether they're in a wheelchair or not. So
wow.
that all of that recognition is a function of the frame of view. So if you think of I'll show you a video in a minute, but if you think of a camera and what the camera can see, and especially if we use a fisheye camera, you can actually have quite a wide angle. And from a distance, because it can identify 6 or more people in the room from 10 meters away. So you can imagine how many people you could see 10 meters away in a camera, right? So yeah, the high resolution cameras these days allow you to see great detail from quite a distance.
Amazing.
Just an interesting side on that is that Canon recently prototyped a camera last year, and it's 250 megapixel camera. And what that means is that you could take a picture of a landscape and maybe a city that was 10 miles away, and you could continue to zoom in and the picture would get clearer of an object 10 miles away.
Amazing. Amazing.
It is, yeah. The limits then become, the lenses and those kinds of things. So we're there. That's a long way off from, that's a prototype situation. But, we recently got cameras that are much higher than the popular 1080p kind of resolution. So we're getting to the point where we're getting twice that resolution and frames per second on a video at 90 frames per second. So, that puts slow motion in a whole different world. And it's been really interesting over the last 2 years. We're like, I would say every 6 months we're changing up our sensors and getting benefits and through that improved speed and resolution all the time. And of course, we moved to a LiDAR sensor, a 360-degree sensor for detecting things as well. So with a LiDAR sensor, it's like a laser that spins, and every 4 degrees it picks up all of the depth data around it. And so the robots can literally see in eyes in the back of their head, right? So
I've seen that on the Google cars, and spinning.
Exactly, same idea, and we're just using it in an indoor environment. So anyway, we've got identifying the client. We could identify where they are because of the space identification under navigation, their likes and dislikes. And then one of the key things they wanted to do was identify activities, because staff have to log a lot of information in order to maintain their government funding and just satisfy families, the activities and what's going on. So identifying movements, speech, body position, just those kinds of things we've got a new team starting. We're starting to drill into these areas of activity recognition, like if someone's lying down, have they fallen? Are they just having fun? Are they having a seizure? Are they, in a wheelchair or not? Are they running? Is there a fight happening? All these things we're working on identifying. There's hundreds of actual different activities that researchers that started in the sports world, looking at football games and soccer and hockey and identifying, who the key player, who had the puck, who had the ball, those kinds of things, and where were they going next, and who was about to receive the ball, all that kind of stuff. They're starting to take that research that they've learned for sports, probably where the big money was, right, in the beginning, and moved it towards this idea of how can that same research and technology be used to help identify situations in a group home, and that might be experienced by, in a unique way, by people with developmental and cognitive disabilities. So we haven't started the smell identifying smell yet, but there are electronic noses that can identify aromas in the air, and so that could identify different scenarios in the group home, like spills or incontinence or whatever. Touch, we've got a team working on, what should the robot feel like? There's a lot of evidence that suggests, just even robots that look like walruses or seals and that can be petted can have can reduce anxiety. So looking at that. Facial expression, we started looking at emotions. We realized we could identify about 12 different emotions from across the room, but we quickly learned that was fleeting, and a lot more research has to go into that, because while I could tell on a picture if someone is smiling, it doesn't always mean they're happy, or if they're angry, it's hard to tell sometimes. So, so there's trending that has to be done there. But at minimum, what we're doing now is that we can send the robot on an inspection. We just verbally tell it, the robot's name is Ether, by the way, and we just say, Ether, do an inspection, and it goes from a room to room on a pre-designated route, and just takes photos of what's going on in those areas and looks for activities that have been flagged for concern, and can send a text or email to the staff member and store it on file for reference if necessary. So those are some of the experiments we're doing. If some of you are wondering about the ethics and privacy of all this,
I was thinking about that.
Yeah, absolutely. Yeah, we've been thinking about that, and so we actually have one team from the University of British Columbia that is one thing that working with the universities is required is they have these really strong ethics reviews, and for any of their projects, we have to go through hoops to get approval to do things, and so we have to show how privacy is respected, how data, how consent is given or assent, and how we actually ended up with a ethics team that is just working on the whole area of how robots will interact with people, and there's two ends to that too. There's the protecting the privacy of clients and staff, but also there's in the UK there's already a ISO standard under development in respecting the rights of robots. So yeah, so someone's really looking that far ahead and saying, at what point maybe a robot reaches the point of singularity where there is intelligence as humans, and some famous people are like Stephen Hawking, are saying that could happen in the next 100 years. Others are saying it could happen in the next 25. So it's certainly exponential growth, and yeah, it's really interesting. So so basically, we're storing that data in a secure way, and therefore the robot can actually get that data back and use it to help people in return. So most of that data involves social interaction, and so we wanted our robot to operate primarily by voice and then be more proactive based on what it sees. Proactivity in robots is the most difficult these days. If any of you have an Alexa or a Google Home or that kind of thing, if you recall, you always have to say, Alexa or Hey Google or Okay Google or whatever the wake word is.
Right.
And that means that it's not proactive. None of the devices that you see today are proactive. In other words, they won't just do something when you walk in the room. You actually have to engage it. Mm-hmm. And so we're working towards making it more proactive. A lot of the technology out there, it's a real double-edged sword, because if something's proactive, it can be a real pain sometimes.
Yeah.
As it tries to interact when it shouldn't. But basically, we're looking at, informed questions, general questions. The robot should deliver instructions, provide feedback, respond to the human, and interact with. One thing that we've had a lot of success with is we've integrated the robot with Office 365 calendar systems, and therefore you can have doctor's appointments and medical appointments, and even recreation like bowling or swimming. Those kinds of things can be on the schedule, and it's accessible by the robot. And because it knows it's you, when it reaches a certain level of confidence that it knows who it's talking about, and it knows whether someone else is in the room, because it knows that, it can start to share information with the client or staff about those appointments. So so that combination of client identification with high confidence and access to appointments, people that know what you're doing can interact with you in a more intimate way. And so that's what we're working towards. So also the snoozling room environment with lots of lights and anxiety reducing features. We're looking at the robot becoming part of that room so that it can monitor and kind of be invisible in that room, and also create environments that reduce anxiety. So we have one specific team in Toronto, and they're working primarily on detecting anxiety, and therefore we can then apply tools to reduce it.
It must be a very difficult thing, because I always worry about, group homes are one thing, but we have many, many people who live in their apartments, maybe with a roommate, but a lot of them are on their own. And, they'll go to a job at the supermarket, then they'll come home and they have no social interaction. So if somebody came into the house and Ether said, hey, how was your day at whatever supermarket, you wonder too, how does it know to stop asking that same question 10 times?
Right. Yeah. Yeah. And a part of that is the storing data is like having a memory, right? And so those are some of the challenges that we have yet to work out. So at this point, we'd just like it to ask the question once,
Right.
Yeah, in a timely manner. Yeah. So, but ultimately, there's going to be, and it might be that the whole machine learning area, the same kinds of tools that allow the robot to learn how to identify people. It can start to record conversations or topics. But I think that the first step is collecting the data and then figuring out how to do something with it.
Right.
Yeah. Yeah, no, that's a good point, though. So I'm going to try to show a couple of videos here. Of course, this is where the technical challenge is. On one side, I'm dealing with the robots. The other side, I'm dealing with today's webcasting technology. But maybe I'll just try an interview. So you should hear the words here. There may be a bit of a delay in the picture, but hopefully the words, this is an interview with people at the group home, and hopefully this will give you a sense of their perspective on it.
And also all these videos are on the keynotes.
That's right, yeah. So this is a group home in Richmond, typical group home, designed for specifically this purpose.
So I've been with DDA for 35 years, so it'll be 35 years in May. My role is I'm the Director of Residential Services. We have group homes in Vancouver and Richmond, and 24/7 group homes, which means that the people in the house have to be supported 24/7. And we also have a supported living model, which require less staff. We have a lot of machines and a lot of mechanical things, but we never really thought of something helping us and assisting us walking around the house. I have to say, it was pretty incredible today to see the reactions of the people living here. There's a new person living here now that wasn't involved in the project when we first started. And I have never seen that individual be so vocal, so happy, so expressive, sitting in her wheelchair, reaching out, trying to look around people to see what was happening. So it actually generates a lot of enthusiasm amongst the people living in the home. Moving away. It's an incredible thing. I think it has so much potential. And you can think of it in different ways. Some people will think of it as an assist, so somebody there to help you out, but also as, I think, a health and safety aspect. If it has an alarm, it can alert staff what's going on, if somebody's falling out of bed, if there's smoke in the house. So I think we don't even realize the potential of it yet.
I'm just going to stop it here and maybe for time be able to show you a couple more things. So there's a team working on the look and feel of the robot. So this is an early prototype of the robot that basically was like the skeleton. And, you know, it started off just like a laptop and a base and sensors, and looking at ways on how that's going to change. But the actual look and feel of it is still a major development project. And another one, maybe I'll show you a social interaction one here. This one also identifies, shows you how it identifies faces. And it also, the talking. So the voice you hear is very much, uses Alexa voice services, but our researchers and developers are developing skills. So if an app is to an iPhone, then a skill is to an Echo Dot or an Alexa. So basically, we're developing custom skills that allow us to give commands and that kind of thing.
Computer, how are you?
Thanks for asking. I've been thinking about a friend. He's a self-driving car, but considering a career change. He says lately it feels like he just wants to.
So I'm just going to stop it there for a minute. So this is on the left-hand side is the original video stream, and it's happening at 30 frames per second. And then we process it, and every 2 frames, we send that to our learning algorithm that identifies any faces. So in this case, it correctly identified Kathy here, and the confidence level was 62%. So depending on the confidence level, we can do different levels of privacy and reveal certain things. So, but you can imagine that's continually changing.
Oh, that way. What else can you say?
Yeah, I remember to take it.
Excuse me, computer, what else is new?
Here's your flash briefing from CBC News.
Computer, go.
Say computer first.
Computer first.
tell me a joke.
Sorry, I'm not sure.
Try that again.
Could you say that? Could you
Say computer.
Peter, could you give me a joke?
A little louder.
Could you give me a joke?
No, sorry, you got to say the computer part first.
Computer, tell me a joke.
Tell me a joke.
Computer,
Computer, would you please start your joke, please? Computer, tell me a joke. Can you tell me a joke, please?
why couldn't the basketball stay in a relationship? He was always on the rebound.
So, gives you an idea there that I didn't want to kind of hide the challenges here, but it's quite challenging getting Kathy here to communicate, and I think that's one of the areas that we're going to work a little more on, like what kind of how can we help Kathy figure out how to actually interact and get what she wants out of the robot. Plus, it has to have more sensitive microphones, and she's got to be able to hear it. And so all these things are just moving up incrementally. Every month it gets better and better in terms of what it can do.
Have you heard about the Talk It app, the voice recognition app?
No, I haven't.
It's in beta, and like Kathy here, she can speak pretty well, but there are so many guys I know that have difficulty making clear speech. And there's an Israeli company, that Raz Mobility, and they're in beta now of this app that basically will establish a vocabulary based upon what you say. So it's like my daughter says "mook" for milk, and then it will instantly translate into understandable speech. So it's sort of like an intermediary that could be used in between somebody that had poor speech and to a public or an Alexa.
Yeah, that's really interesting.
Device, and it's pretty much supposedly, they don't have the product out yet, but they say that they're getting pretty much a real-time response between the instant translation. So.
Yeah, that's so interesting. I think that's one of the side benefits is that because the robot needs to collect data, both sound and image data all the time to navigate and interact. And the machine learning, basically it's like you take a situation like a face, you put the square around the face, and then you identify who it is, and that learning process is a process of labeling. So every time you see Kathy, it gets labeled that way. And I can see that with voice and verbal things as well. It's that the same tools you could, as long as you can label a word as milk, right? Then you can actually use a neural network to do the training. And I often wonder that we'll discover that we'll collect this data, and then we'll look at certain behaviors, physical behaviors or gestures, and where a human may not have been able to detect a pattern, that because of the vast amount of data, the robot and the computer will start to see patterns that we didn't realize were there, right? And yeah, so it's amazing potential.
Hopefully relieve a lot of anxiety or frustration too.
That's right, yeah. So I'll just show a little bit of this navigation. So this is the part where it's drawing a map of the group home. So what you're seeing here is in the top left is just a video of the robot from a person's point of view. The bottom one is what the robot's seeing. So that's the exact image coming from the computer as it moves along. And then down below is a depth camera view where the lighter the gray, the further it is away. So basically, you can measure down to millimeters how far something is away, and therefore you can start to draw the map, which is on the right-hand side. And the gray area is a map bounded by walls. So when the solid object is seen, it draws a wall, and then the red line is the vector or the direction that the robot is going. So there's a learning process. You drive it around with a joystick the first time so that it can get to understand the group home, but then eventually it draws a map, and you can label spaces, and therefore it kind of knows where it is.
Mm-hmm.
So I'll just kind of accelerate this a bit. So eventually, as you can see, you start to get a map forming of the whole group home, and it's designed with a hallway that goes around in a circle. And yeah, so it's that whole process gets better every time we work on it.
Right. How long a cycle is it from like when the ether sees a new person to when it recognizes somebody again?
So we use a database similar to that Facebook and Google might use, with over 1 million faces, and that is the base and that took several weeks for them to train. But once it was trained, what you can do is you can have your own people, like say all 10 possible people in a group home, and you take you just have to have maybe 250 frames of video, like 250 pictures of them at different angles, and you have all 10 people, 250 frames each, right? So you have a couple thousand, 3,000 or so images. You feed that in, and it takes 5 minutes to merge that with the database of millions, and then and that's about it. So we are we're going to go to a conference, and our next conference trick is going to be that someone will be able to come up to Ether and give their permission for Ether to recognize them, and then they can come back 10 minutes later and it'll recognize them.
That's amazing.
So we're going to try that with 1,000 people coming up, but it takes a little bit longer to learn as that gets bigger, as it goes from 10 to 1,000.
Sure.
But that's the realm. Like 10 is 5 minutes. 100 probably 15 minutes, that kind of thing.
Yeah.
Yeah.
I could
So
see
definitely
such telehealth applications in here too.
Yeah.
I wonder if you added up all the hours that people spend in clinic visits during the week from group homes, and how a telehealth visit from a doctor or a therapist and stuff maybe it would save so much time and trouble.
Yeah, indeed.
Yeah.
So this is the second last video.
Hello, I am Ether, a collaborative service robot. Please state a command.
Go to Carol's room.
Would you like me to go to Carol's bathroom?
No.
Okay, let me know if you would like me to go somewhere.
Computer, ask Ether to go to Carol's room.
Would you like me to go to Carol's room?
Yes.
Going to Carol's room.
So that's just an example of how we've developed skills using Alexa voice services, and the wake word we use instead of Alexa is we use computer, more in the Star Trek vein. But eventually we hope to have our own wake word, but even training a wake word can require millions of voice samples, so it's challenging.
Sure.
And then we say ask Ether, so we're basically saying to Alexa, ask Ether to do something, and that something is a skill that we've created. So there's this communication back and forth, but it's really unlimited. Once you can do that with one command, it just opened the door to all kinds of things that we could ask Ether to do.
What an amazing future. In the interest of time, I'm going to let you go, but you did an absolutely fantastic presentation. And some of the videos are available on your website, right? The 3S.
That's right.
So,
yeah.
You know, if anybody's interested, just go to that website. You can download all this material. And this is such a complex topic that maybe down the road we can invite you back again and find out how you're doing with Ether and the whole project, because it's absolutely fantastic. Absolutely fantastic.
Great, thank you. And we're looking for research partners at this point, so in North America. So if anyone on the call is interested or knows a university or maybe another business in technology, would love to hear from you.
Okay, we'll keep it in mind. I know a lot of people over this side. Okay.
John,
thank you so much. You're a very generous person. I really appreciate it. Have a wonderful day.
All right, thanks.